So I'm really excited about this next one. We are going to be learning about source generators from my friend David, and he's been. You've been doing all kinds of stuff lately. You wrote an online, like a web tool for evaluating source
Yep.
generators and using Blazor, right?
Yeah, that's right. I kind of beat Visual Studio to the punch, and the Visual Studio tooling wasn't ready yet, so I had to take matters into my own hands. But I'm glad to say Visual Studio has caught up and surpassed me, so I don't have to renew the domain next year.
Wow. Okay. Well, we're short on time, so I'll just turn it right over to you. So let's see what you got.
All right, let's talk fast. Hello, YouTube. Hello, Twitter. Hello, everybody. Let's talk source generators. So source generation in general is something that's been around for many, many years, and there's lots of different ways to do it. You can use Codesmith, you can use T4 templates, you can write your own MS build tasks. You could do stuff after the compiler by using Foddy or PostSharp. What I'm going to talk about specifically is C#9 source generators, which is a new feature in the .NET 5 C#9 tooling that lets you do this, but as part of the compiler. So let's talk about what that means. This is the sort of highest level view of the C# compiler that you'll get. This is what happens when you compile your code. So you have your C# files on the left-hand side there, and they get sent into the compiler, and of course we get a DLL out the other end. But what really happens inside the compiler? There's a few different phases. Some of those, not all of them, are. So the first one is the parse phase, and what that does is it takes your C# code and it turns it into an object model, which is a syntax tree. In the C# compiler's case, it's called the concrete syntax tree. That's just because it contains every little bit of information about all the white space, about everything in your code, and you can go back from a tree to source code. But that doesn't matter. Essentially, this is just a series of C# objects that represent what's in your file. It doesn't have a lot of smarts about types and things. That comes later, specifically in the compile phase. So your syntax trees are sent into the compile phase, and that produces a compilation. A compilation has two things in it. It has your syntax trees, which is exactly what was in your code, and then it has your symbolic information. And those are the types that you're using. So when you use the keyword string, the parser knows that's a keyword, but it's up to the compilation to know, oh, well, that's a system.string, and here's the DLL it comes from. So what's cool with C#9 is if you have a source generator in the mix, what happens now after the compile phase is that compilation, so that syntax tree and those symbolic information, they get sent to a source generator. A source generator is just a DLL that you provide. You tell the compiler, hey, here's somewhere I want you to load source generators from. It can be whatever code you want because you just write a DLL. That source generator gets to run, gets to look at those syntax trees, gets to look at that compilation, and it generates a string, which is new source, and it can generate more than one. That new source gets parsed, becomes a syntax tree, gets compiled, becomes a compilation, and then that compilation is melded together with the compilation from your project to finally go to the emit phase and become IL, and then out the door to a project, to a DLL. So with C#9 source generators, what you can do is you can hook into the compiler pipeline and run some of your code, and you can access some of that internal data structures that the compiler has, which is super powerful. So at this point, usually people have some questions, and I'm going to try and guess what they are. Firstly, does the source you generate exist on disk? Not by default. You can do that. There is an option. It's called emit compiler generated files. This is sort of the first gut feeling what everyone wants to do is, hey, I've written a source generator. It generates some source. Let me see it. So that option is there for you, but you shouldn't rely on it. And in fact, I personally, and I've written a few of these, I've never needed it. I've never turned it on. And I'll show you in Visual Studio why you probably don't need it a bit later. Can you have multiple source generators? Absolutely. You can have as many as you like. One of the big sort of design considerations about whether C# source generators is the right choice for you is that source generators can't rely on each other. You can't have one source generator that generates, a bunch of classes and then expect another source generator to pick up those classes and do something with them. Each one is independent and they all contribute back to the main project, but they don't see each other's work. So that's a big design consideration that might rule this out as a solution for you. And that's fine. This is not meant to replace any existing technology. This is just another option. do we really have to produce strings? So what happens is you start to write a source generator and you start to produce these strings and use a string builder, and then you have to output a quotation mark, and now I've got to double quote it. But what if I want to output a string in my source? Well, now I've got to double quote my double quotation marks, and it's a pain. There is other ways to generate source, but at the end of the day, you have to produce a string for a source generator because that is what the compiler is really good at compiling. That's what the compiler is hardened at compiling, so it's not going to crash. It's not going to expose any bugs. So yes, at the end of the day, you need to have a string. But there are other object models you can use, and then you can convert to a string just before you sort of add them. Can they change code? This is the other biggest design factor to consider that might rule this out as for your scenarios. They cannot change existing code. What is in the project that the source generator is running against does not change. It cannot be touched. This is very different to existing source generation options. So again, this is not meant to replace those features, but it is a very big design consideration you should think about. There's some little tricks you can do, I'll talk about later though, that maybe can help. And then how's the IDE experience? It's really good if you're consuming them, which is what most people are going to do. If you're writing source generators, it can be a little bit annoying because Visual Studio, being a .NET framework app, it can't unload DLLs. Therefore, if you have a source generator and you change it and then you expect Visual Studio to pick up the new one, that can be a little bit annoying. But for consumers, it's great. And it's going to get better for authors as time progresses. So what can you do with them? In my opinion, there's three basic buckets for the types of source generators people might want to create. The first one is with an eye to performance. So there's a lot of stuff where we do a lot of work at runtime via reflection. Maybe at app startup, we have to go and discover a bunch of stuff for a DI container, or for ASP.NET routing, for example, would have to do this to discover your controllers. If that work can be swapped to happening at compile time, right? If all of that data is present at compile time, then you're saving your users all of that time, and you're basically putting it on your build server instead of your users' machines, which is a huge benefit potentially. The other one is for processing external files. So source generators can access other files in your projects. And so you might use them to generate strongly typed wrappers for XML files or JSON files or CSV files. You can use them to even do, well, actually, I think I've got an example later. Talk about that then. And basically, at the end of the day, you can just use them to automate things. So if you're going to implement iNotify property changed, or you've got to create dependency properties for all of your normal properties, things like AutoMapper exist for this same reason. Sometimes it's just boring to write code, or it's repetitive, or it's error prone. And so potentially just the act of generating could be the win. Source generators can also report diagnostics. This is another huge win, particularly in the case where you're doing something at compile time instead of at runtime. So say you're building a DI container. If you're building a DI container and you don't have an implementation for some interface that is required, that's going to throw an exception at runtime, probably at app startup. If you can convert that to a source generator, you can break the build when someone forgets to check in an implementation. And that's a much faster way to detect these issues. Now, you can also write Roslyn analyzers. Don't use source generators to write analyzers. Analyzers still exist. But it is nice to know that as part of generation, if you find errors, you can report them immediately. So accessing additional files, I briefly talked about this. But basically, you can just access whatever is in the project that is added via an additional files element. A friend of mine, with that link down the bottom, he created a transpiler that takes a language that doesn't support .NET. You add the source code for that language as additional files. He wrote a source generator that is a transpiler that converts it to C#. Roslyn then compiles that C# into a DLL, and all of a sudden, we have a new .NET language. So you can do all sorts of wacky things with additional files. Partial methods. I'm trying to whip through this so I can get to the demo. Partial methods. So I said that source generators can't change code, and that's true, but there's tricks. Partial method is one trick to allow you to sort of augment a little bit the code. So partial methods have been in C# for a while, and the way they work is you define a method signature, you call that method somewhere in your code, essentially creating a hole that will be plugged in with some real code later. And then optionally, you can provide an implementation for that method. Now, it's optional, and if you don't provide an implementation, that method call just gets removed. And because of that, these method calls, they can't change anything. So they can't have return types, they can't have output parameters, they can't have access modifiers. In C#9, because we got source generators and because partial methods become so much more useful, those rules are completely flipped on their heads. You can now have return types, you can have output parameters, and you can have access modifiers. But if you have any one of those things, you have to provide a method body, which is fine in the source generator case because your source generator is going to provide that method body. So this is a way you can't change code, but you can sort of define a little hole here where you know a source generator will be able to fill in the gaps. And so in the middle of the method, you could call some really annoying method to write and have the source generator fill that in, and it's as though it had changed that method. It didn't really, but we can squint and pretend. So how do we actually reference them and define them? Well, it's pretty easy. So on the top left here, over here and over here, two different alternatives to reference source generators. One as a DLL, just with an analyzer element, and the other one as a project reference, but still telling MS-Build that it's an analyzer type. And importantly, we say don't reference the output assembly. So when MS-Build compiles this project, we don't actually want our consuming project to reference our source generator. It's not a dependency. You don't have to deploy source generators. They don't go anywhere, but we just need it to be associated essentially. And then the actual source generator, which is down here, is simply a net standard 2 project, references a couple of Roslyn packages from NuGet, no big deal. These version numbers, are not the current ones, but that's all right. And then to define the actual source generator, it's just a class that is tagged with this generator attribute. That's how the compiler sort of discovers the source generator. It implements iSourceGenerator, and then it just has 2 methods. One is initialize, where it gets given some context and you can do some initialization work. And then one is execute, which is simply generate some code. And all you do is you call context.addSource, give it a file name, doesn't have to be unique. Well, it has to be unique for your generator. It doesn't have to be like unique to the project. So you don't have to go and calculate anything. It's not difficult. And you just give it the string that is the source. It's really that simple. This source generator here on this slide totally works. It generates a class called foo. Debugging can be a challenge. So there's a couple of different ways. Debugger.launch is the easiest way, but can be really noisy. Turns out if you're using VS, VS will compile your code quite often, and you might end up with lots of requests from the debugger to try and debug something. The other option is a generator driver, which is a class inside Roslyn. It's in the Roslyn SDK, and you can use that to run your generator. That's in fact what the compiler internally uses as well. And so you can use that to write some test console apps. That's why I usually start, where I write a generator, I write a console app, and when I hit F5, it's going to run my generator and it's going to output what I generated to the console. And I just use that as I'm starting up. And then you can, of course, use that to run unit tests and test your generator properly. I've got a couple of links there to put in. So source generator template is a little repo that I put together, and it's just got 4 projects in it that is the starting point to any generator I wrote. It's got a console app, which is like the product. That's the thing we're going to run our generator against. It's got a source generator, and it's got a test console app and unit tests like I just described that use generator driver. So I use that as a starting point. If you want to get more serious about things, Chris has written a product called Kitatas. Chris is the developer on the compiler team who wrote all of the source generator stuff. So he knows what he's doing. And Kitatas is designed to enable debugging of source generators and analyzers. It's an MS-Build SDK. It's got a .NET Global tool. It's a much more well thought out system. And then sourcegen.dev, if you really want to just sort of play around and you want to, without digging in too much, sourcegen.dev is that website that John was mentioning at the start that I wrote. And that is probably the easiest way to get going. You basically get 2 boxes on the screen where you can type code. One is the program, one is the source generator. You can see what it generates and you can see what it outputs. But let's do some demos because that's what we're all here for. So one of the source generators I wrote was for the Windows Forms repository. A friend of mine nerd sniped me and said, hey, our enum validation code is a little complicated. Could we use a source generator? And I had a look, and yes, we could. So this is the old code. This is what essentially my source generator is replacing. And if we have a look here, it's about 200 lines in this client utils class, and it has a bunch of these isEnum valid methods. And to call these, you have to pass in the type of the enum you want to validate, what the value you're validating is, what's the minimum value this enum could be, and what's the maximum value this enum could be. The validation itself is not very complicated. But the issue here is there's a bit of a tech debt issue, right? we have to keep updating these arguments. If we add something new to our enum, we have to find all the calls to is enum valid for that enum and update the values that we're passing in to these things. Otherwise, our validation won't be right. To try to tackle that, in debug mode, there's this code here, which is down here, which validates our validation code. And this validation can be expensive and it can be a memory hog. So we have this caching and there's a max size for it. And if it's too bloated, it clears it out and then it has to start again. And all in all, it just gets a bit complicated. And there's a bunch of these overloads. So this one checks for maximum number of bits turned on using these bit operations. There's this one where you have to pass in the mask of all values. It's just a bit of a pain, and it's not that it's slow, it's actually fast, but it's had to do all these sort of hacky things to get it to be as fast as possible because we don't want our runtime validation to be slow. So what I did was replace it with a source generator, which is essentially this method call. So this method here does not exist. It is generated at compile time by my source generator. Now what I can do in Visual Studio is I can right click on it and I can say, go to definition, or I can press F12. Visual Studio knows how to read the generated source out of the compilation, and it shows it to me. So this is, you can see here, it says generated. It says, hey, you can't edit this. It's generated by this source generator. Let me just drag this over here and show you how cool source generator files are. So this method here is validating this simple enum type. That's this one over here. And you can see all it does is it casts the enum we want to validate to an int, and then it checks, is the int between 0 and 1? If it is, great, we return, no problems. If it's not, we throw an exception. That's all the old validation did. That's all this validation does. And so you look at that and you think, well, that's basically what the old one did. It's not very exciting. But watch what happens if I start to write a third value for this enum. As soon as I type the T, or the TH, this 1 has changed to a 2. Now, I haven't saved the file, right? This isn't even committed to disk, but because the compiler is running inside Visual Studio, this validation is automatically up to date. So that tech debt issue I talked about is completely gone. As soon as you do anything to affect that validation, to affect what the source generator is going to produce, it will run again and it will be correct. So I can finish typing this, it doesn't change. If I set this to a 7, the validation changes. Now we're checking between 0 and 1 and we're checking 7. If I change this to be 14, we now have a weird enum, but that's okay. Our enum generator responds. So rather than having multiple different options for how to validate an enum and having to call the right one, we've got one method, it does whatever it needs to do. Rather than having complicated code or possibly slow code, like this could, the old code could have used, and probably did originally, use reflection to do this validation, and that would have been a bit slow. So this one, the code is as fast as it can be, to the extent of, it will even do one if check if it can get away with it. All of this is powered by the fact that your source generator accesses what the compiler sees, right? That's how it works as soon as I start typing without even saving. It's because it's accessing those syntax nodes that the compiler has produced in the parse phase. What that means is you get to be as efficient as possible. So not only is this a tech debt thing, this is also saving us work. You'll see here there's 2 validate methods, one for this enum and one for this enum. The interesting thing about this isn't that the source generator is finding the enums in this file and generating methods for them. It's actually looking at this code that I am running, and it is finding the calls to the validate method. It is finding exactly which enums I am asking it to validate. So if I comment out this line of code, that second method goes away completely. So talk about efficiency. We are generating the absolute minimum we have to get the job done. Imagine what this would have been with reflection, looking for, finding the enum type, pulling out the values, etc. And you start to see some really cool benefits. The really interesting thing about this is because this is accessing internal syntax trees, you can see my code here now doesn't compile. I haven't finished this method call. But my generator has actually generated the validate method already, because the compiler has sort of constructed enough of its model that my generator can run. It can see the validate call, it can read the argument. The fact that it doesn't compile, that doesn't matter. So your generator is always going to be up to date. Let's have a quick look at how the generator works, because we have some time. I've managed to be fast, hopefully not too fast, but I want to leave time for questions. So this is the generator. There's a couple of things to point out. So firstly, we have this stub. Actually, I should show this. What this is if I comment out both of these calls, and I can't do that because I need to press F12 first. There. If I comment out both of these calls, there's no validate method defined, therefore it won't generate anything. The problem with that is that as I'm typing in IntelliSense, I'm not going to see the validate method because it doesn't exist. I'd have to magically know to call it. So this stub method, this is a good practice to do to generate out. At the very worst, if you're not going to generate anything, generate the sort of the structure of what you might need. It just helps with IntelliSense and things. We have our initialize method, and in there we do this thing called register for syntax notifications. What that says is, hey compiler, every time you see a syntax node, tell this thing about it. We'll have a look at that in a minute. And then our execute is the thing that actually does the generation, and you can see here we are pulling out our syntax receiver and we're going to work on it. So the syntax receiver is this thing. This has one method. It says on visit syntax node, which is essentially called every single time for every node that the compiler sees. And so all we do here is we collect up what we're interested in. This is a very common pattern with source generators. Collect what you're interested in and put it in an object model. Then process that object model and put it into a better form, and then finally take that form and generate a string from it. But so here we're just saying, hey, if this node is an invocation, now this is an internal Roslyn type that is a method invocation. Looking at the syntax nodes, if you look at them with the debugger, the various syntax visualizers, if you use SharpLab has a syntax tree visualizer, you start to get the feel for how the language fits together, and it's relatively easy to understand for the most part. There's a few little edge cases, but there's plenty of good talks on that as well. But so we say, hey, is this a method invocation? Does it have less than or equal to 2 arguments? Because we know our validate method has 2. Is it for a method called validate? Is it on a type called enumValidate? Like, we're just narrowing down our scenarios. Is this a node we're interested in? And then if it is, all we do is add it to this list. So all we're doing here is we're collecting. So we want this to be super fast because this is happening in the compiler for every syntax node. So all we do here is collect. Back over in our execute, we've got our arguments to validate by pulling it out of the receiver. And now we're going to generate our model that represents what we want to do, which is this method. And this is not very exciting for this generator. It goes through each argument we want to validate. It gets the semantic model. So that's that symbolic information, basically to check types. Hey, is this an enum? Is it something we found before? If it is, don't worry about it. Is it a flags attribute? Because flags have slightly different validation. And then we just store this in our own data type here, which is just essentially a DTO to say, hey, here's something we're going to process later. Back up the top here. Sorry for the scrolling. So we've got our list of, essentially this is our list of methods we need to produce. You can think of it. And so all we do is we go through and we generate that list. So we generate a namespace, a class, a method signature, and we generate a method body. So this is where you can see that we're just generating strings, but in my opinion, it's not that bad. It's not that hideously ugly. Yeah, working with indents is a little bit annoying, but you get used to it. And if you break down the methods into as smaller chunks as possible, I think it actually gets pretty manageable. So this method here generates just a stub of a method, and then it calls this method to generate the body. This body always contains this line, it always contains this line, but then it calls another method, right? So have it very small, very specific tasks, and you're fine. And then you can see here with the flags one's a great example, where if you were using reflection to validate a flags enum, you would loop through all of the values and you would add them together to get the total, and then you'd validate that. And that's exactly what we're doing. We're just doing it at compile time. So this runs inside the compiler. And so what we produce is the smallest possible code, right? We don't need to loop through these values at runtime because we know the answer is going to be 15 or whatever. Let's just put 15 in our generated source. In fact, that's exactly what happens. If I go back to here and drag this over again. So again, as soon as I add in flags here, you can see the validation changed. It's add 1 because it's not very exciting. If we add in some more, some proper enum values, and 5th equals 8 because that's a sensible sentence. There we go, 15. So that's it. I want to leave some time for questions, so hopefully there are some. Please do ask. I know that was a whirlwind. I'm going to, no, my times are over there. There's nothing to see. Hello, John.
Hey, that was amazing.
Thank you.
As I expected. So,
I feel like it was a sprint.
it was definitely a sprint. We give you a short amount of time. One question that came up was, what would the advantages be compared to T4 templates? And kind of in the scope of that too, something I was thinking about is this is a very code focused generation, right? You're appending
Yes.
one line at a time. How does this compare? And is there a way to use some sort of templating for like, broader parts of it?
Yeah, so that's it's a good question. T4 is an interesting case because T4 has some advantages that this doesn't have, and it has some, well, I don't know if it has disadvantages. It's very different. T4, you have to think of T4 as a Visual Studio feature, right? So it's got a really good editor. It's a really nice way to generate lots of code because you can see the code as it's going to appear, whereas this, you're outputting strings. It's a bit more annoying. But this runs in the compiler, which means it's going to run on your CI server. It's going to run on your Linux machine at the command line. Everywhere the compiler runs, your source generator runs. So it's easier to sort of roll out in that sense. I haven't used T4 for a while, but getting it to run on a build server was a pain last time I tried.
Yeah.
On the other hand, T4 can access things about your project in VS that this can't access, right? So there's definitely trade-offs. As far as generating the code, there's a thing in Roslyn called a syntax factory, which you can use to generate the syntax trees and then essentially just call toString at the end. There's a website called roslynquota.azurewebsites.net, which you can type in some code and it will output what the syntax factory calls are needed to generate that as a head start. That's a good way to do it as a start, but the big issue is Roslyn syntax trees are really verbose because they contain literally every character in your source code.
Right.
So I don't know. I think there's a couple of NuGet packages around that sort of try to do this object model stuff. I suspect we'll see more of those sort of emerge as source generators become a thing. But at the moment, there's not sort of one gold standard, let's say.
Okay. Let me see. We're just about done. We've got time for maybe one or two. Let me see. Oh, no, that's not appropriate. That's here. Let me see. I'm in some weird. Oh, well, question here. How does this, is there an impact,
Yeah.
build times, dev time, whatever?
There definitely can be. The biggest problem of source generators is that you have to write them yourself. And so therefore, if you write bad code, you will slow down things.
Yeah.
So I have a source generated DI system that I wrote for a personal project, and I wrote it, and my game that it's for was a WPF app and everything was fine. And then I decided to switch to a WinForms app. And as soon as I did that, my Visual Studio experience ground to a halt because my source generator was slowing down the whole thing.
Yeah.
Now, I found the problem and I fixed it. It is definitely something you need to be considerate of, is you have to think about performance because those compilations happen a lot. At the same time, this is the first release of source generators and there's going to be more work done on them and to get them more efficient and to cache more stuff in the compiler, etc. So things will get better as well. But yes, it is easy. If you write a while loop that doesn't end in your source generator, you can say goodbye to Visual Studio. This is why your source generator, you don't want to be pulling information from a website or a database to inform the generation. Stick to files that MS Build knows about, and then you'll be hopefully okay.
Okay. Great. Well, this is amazing. So I really appreciated it. I'm going to have to watch that again. And but great. So unfortunately, I have to say goodbye and move on to the next.
Thanks for having me.
So great.